Champaign County Agriculture Today with your host, Dennis Riggs.
Hello and welcome to Champaign County Agriculture Today. My name is Dennis Riggs, your host for the next half hour as we explore further the intricacies of Champaign County agriculture. Today, you've always heard the old saying, what came first, the chicken or the egg? Well, we're going to talk about that agriculturally, except we're going to take it from the science of crops. And we're going to talk about seeds. Where did the first seed come from and why are they so important to the food and the fiber that we grow here in East Central Illinois? With me today are two gentlemen. They're going to address those questions and help understand better what seeds are all about. And we have Doug Miller, who is Director of Field Services with Illinois Crop Improvement Association, and Gary Cook, who is a registered seed technologist with Illinois Crop Improvement. Doug, let's start out with you. Where's hometown? Where did you come from? And what do you do for Illinois Crop Improvement?
Hometown is in Arga, Illinois, in Iroquois County. I've been with the Illinois Crop Improvement Association 12 years now. I manage the field inspections that occur for seed crops and also work with the genetic testing in the greenhouse during the winter.
Very good. Gary, you are a registered seed technologist. Now tell us what that title entails and also where's your hometown?
Okay, basically a registered seed technologist is a accredited individual as part of the Society of Commercial Seed Technologists. We're a national organization, actually international organization, including Canada and the U.S. We basically pass an exam that is basically study the ins and outs of what seed testing is about. That's basically our thing. I'm originally from Atlanta, Illinois. I've been with the Illinois Crop Improvement for 30 years. Went to Western Illinois University before I joined them, and my father was involved in a seed company. It was kind of a natural.
They've been around for a long time with the seed business. Seeds are so important. People, if you think about that, where would we be without seeds? Where we wouldn't. Vegetables, grass in our garden, trees. I mean, it all starts from the seed. But let's talk about Illinois Crop Improvement. What is the Illinois Crop Improvement Association?
Illinois Crop Improvement started out as the seed certification agency for the state of Illinois. We're authorized through the plant. Doug, help me out there.
Federal Seed Act.
Federal Seed Act, a federal legislative issue. Okay.
The Illinois Department of Ag is responsible for the activities in Illinois, and then they authorize us through the Illinois Seed Law to certify seeds in the state.
Very good. Where does the funding come to keep that business going? It's a pretty good sized business out here in the Interstate Research Park in northern Champaign. Who funds this operation?
It's basically funded by our producer members and the folks we do testing for, which actually we can do testing for other than our members. So we do clients basically all over the U.S., including international clients.
Very good. Well, let's just start out. Where did the first seed come from? And I know we're kind of getting very generic here in general, but how did seeds start?
Basically, from my understanding of botany, seeds developed over time, starting out with the simplest type of plants, actually starting with spore-bearing plants and working up to more advanced plants till we arrived at the plants we're working with now, which are basically the angiosperms, which are basically a true seed type plant. So it's basically been a long process. At least that's what evolutionary theory tells us.
Okay.
I'm not necessarily a believer in that, but that's...
Well, it all had to start somewhere, right. That's for sure.
Seeds are very, very complicated organisms.
And Doug, you get to go in different parts of the world or in different parts of the seed growing areas. Are there different seeds depending on what area you're from?
Yes, and it just depends on the region you're in, what the locally adapted types are that have found their environment that they thrive in, and depending on whether you're in Costa Rica or whether you're in central Illinois, you may be able to grow some of the same crops, but very much so you'll see the locally adapted crops that people have managed to tend and bring along, because man and seeds have kind of gone hand in hand, and many of the crops that we have now would not be able to sustain themselves without man. Corn would probably not be with us. We need someone in there to mechanically, spread the seeds and replant those crops.
So they're pretty dependent upon each other, and that's probably a good thing, and that's why we all have jobs, whether it be as farmers or as seed technologists.
Right.
Well, let's start out with our first slide here today, and that's pretty basic. We're going to put up a slide, and if you would there, Gary, tell us what this slide is. Is it a seed? Is it a plant? What do we got there?
This is a true seed. It's actually a soybean seed. It's a dicot, which basically means it has two cotyledons or two rudimentary seed parts that actually is the storage for the nutrients for the immature plant.
So not only is it the growing deal, it's not the growing organism, but also it's kind of a backpack of energy along with it
Exactly
at the same
right.
time.
It's its lunch until it gets up to where they for the sunlight to produce.
Carries its own lunch. I like that. Well, let's go to slide number 2. We saw the first slide, we had some soybeans, and that's pretty typical. People have seen beans, and even the edible type, they all look about the same. In slide number 2, we see that seeds can be of different size. What can you tell me about that, Gary?
Basically, there's a wide range in the size of seeds, depending on the plant it's produced from. Our testing is basically all the way from the size of tobacco seed, which is very, very tiny. Not quite the smallest seed. It's a very, very seed all the way up till lima beans. But the largest seed that in the world is actually the double coconut, which is about this big around.
About a basketball, or a little bit bigger than a basketball. Okay, a little bit bigger than a basketball. And the smallest one, tobacco or
actually, orchid is the smallest seed. So it's a little, orchid is a little bit smaller than the tobacco, and tobacco is about like dust. So
okay.
So it's a really tiny seed.
Very interesting. All right, well, let's move on then to slide number 3. I'm going to turn this over to you, Doug. We see, in slide number 1, we saw the soybean seed itself. Now, here we see some development. Tell me what's going on in this slide, Doug.
Well, basically what we have here are soybean seedlings, and seed, of course, is basically the precursor to the seedling. As we said before, a soybean or a seed is a baby plant in a box with its lunch. So basically what we're seeing here is that the transition from seed to the actual plant.
On the far left-hand side, how old is that seedling? It's been planted. How long has it been since it was planted?
I would say probably 2 to 3 days. Would that be correct, Gary?
Getting
And then
started.
as you keep going, probably add another additional day for the middle 2, and then probably 5 to 6, almost 7 days for the one that has its unifoliates out.
Okay. We talk about Illinois crop improvement, and of course we're very concerned about the crop seeds that are out there. But in slide number 4, we're going to put up next, we know you folks not only deal with crops, but you also deal with very many other type of plants. So in slide number 4, we have an example of several different things. What's growing here? That's not soybeans.
No, and basically a plant out of place is what you would call a weed. A weed is basically a plant out of place. And what it looks like here to me is that they're doing some trials in the greenhouse, and weed scientists often need seeds from different weed species. They also need them to be pure, true to type, be exactly what they need to have to germinate to do their studies, and look at different things that can help control weeds in some of the crops. Or from the other side of it, we also work with what are called native species, and we have programs such as Source Identified that helps people identify types of seed that will grow in their area, because there are different ecotypes, and if you take a native seed out of its area, it may not perform as well or may not perform at all. So if you're a homeowner interested in native species for ornamental sake, you just need to make sure that you're purchasing something that's adapted to your ecotype.
One thing I've always wanted to ask, and farmers have one chance each year to plant the correct seed in their fields to grow the crop, the intended crop, whether it be wheat or oats or corn or soybeans or whatever it is. Is there a chance, Doug, that they could plant the wrong seed and it wouldn't work?
Very much so. With today's technology, with the biotechnology, if you plant a non-Roundup ready soybean and you spray it with Roundup, you've missed your chance, because you will kill that crop since it doesn't have the resistance gene to the Roundup herbicide. Typically, there isn't such a drastic mistake that you intend to plant corn and up come tomatoes by any means. But yeah, there are issues with maturity. We have had situations where someone told us it was what they called a Group 0 soybean, and basically there's different maturity groups. In Illinois, Northern Illinois is Group 2, middle of Illinois, Group 3, Group 4, and it's all about how many days it takes to mature, and in response to the day length. And we had some things in Minnesota that we thought were adapted to that area, and they were not. And they would not set seed. They would get frosted out and would not. They wouldn't be able to harvest anything off of them because they were the wrong maturity for that area.
Many times we see people that travel to foreign lands or even just different parts of the U.S. and will bring back a palm tree and want to plant a palm tree here in East Central Illinois. Is that a good idea?
No, from several standpoints, that's not a good idea. Illinois Crop Improvement's also accredited under the National Seed Health System, and there are phytosanitary rules, meaning that seeds can also carry diseases. They can also be sick, and we don't want to bring anything in, whatever the crop is, whatever the seed is. You may be bringing in something that's potentially dangerous to our livelihoods and the areas that are outside of our country. You should leave anything that you find there because there's potential to transfer disease. And then, of course, there's the potential that simply the seed will not work.
Mm-hmm.
You can try your best, and if you don't understand the physiology of the seed, whether it needs to be treated before it, whether it needs a cold treatment before it'll germ, or whether it needs to be scarified, or the seed coat needs to be abraded before it'll germinate, those are the kind of things that most people don't know about.
Gosh, this sounds like serious business, Doug. I mean, it sounds like, in fact, a life and death for the plant, and of course, economic life and death for the farmer. Well, Gary, we're going to bring up slide number 5, which is going to be a picture of some lima beans growing in a pot. Tell us what you do, what type of activity goes on at Illinois Crop Improvement Association. What might be happening in this example?
Well, so basically, I think from this example, they're looking for seed that are either normal seedlings or abnormal seedlings. They're probably doing a seed quality test of some type. The plant not only needs to produce, or the seed not only needs to produce a seedling, but the seedling has to be such that it will produce a healthy plant in the field. So it has to have those parts when it comes out of the ground that it's going to be able to produce food, or it's going to have enough reserves until it's time for the plant to produce food.
Do all plants produce seedlings, or do some plants not? I guess the example I'm kind of thinking in the top of my mind is watermelon. And we've all heard of seedless watermelons, yep. And of course everybody wonders how are you going to grow the crop next year? How does that work?
Well, basically there are seeds in seedless watermelon. You plant seeds to produce seedless watermelon. They're modified from what a normal seeded watermelon would be. So the hybrid that you're buying won't produce as many seeds or as tough a seeds as what a seeded watermelon would.
Are there genetic lines in crops and thus transferred to seeds just like there are in humans? Can you trace a seed backwards to its origins?
Yes. There's genetic fingerprinting they can do on seeds, on plants, to determine the location, or in some cases now they're doing testing on new hybrids that are being developed to determine whether somebody has pirated other genetic material from another company. So, but yes, they can trace things back. It's a pretty involved process. Mm-hmm. But
so you might say there's fingerprints as well on seeds as they grow.
Exactly right.
Well, we've got the seed thing figured out here, and it's an important business, and we have to make sure we've got the right stuff. Let's talk about planting seeds. Slide number 6 that we're going to show next is going to talk about the actual process of planting. Now, I know, Doug, you're involved in planting seeds and watching things happen around, make sure it's done correctly. This is a picture of what? What's this device here?
Well, I'm not exactly involved directly with planting, but obviously this is the back of a planter box on top, which carries the seed, and of course they need to make a cut in the soil for the seed to have good contact with the soil. Primarily what I do is make sure that the seeds that they say have been planted are what actually comes up and what is genetically pure, and that isolation, things like that distance between crops is appropriate, and and so on and so forth.
Okay. Well, of course, this is a picture of a single unit that would plant a single row. We're going to move on to number 7, which of course is what folks around East Central Illinois are probably referred to more as what they see out in the fields, and that's a whole planter. Here, Gary, we see a farmer out there to the far left, and he's checking his seeds. For the seed to make it this far, so the farmer is actually planting something, how many steps has it gone through?
Well, basically, of course, the hybrid seed is produced doing the detasseling work that is necessary in the summer before, and they do conditioning work to make it so it's plantable. They're also doing seed quality work, such as our lab does, to make sure that it's uniform in not only germination but vigor. So the farmer's going to be satisfied with that work. And if it has genetic traits added to it, they're also doing that testing before it's sold to the farmer to make sure the seed quality is up to standard.
Is it pretty common, we see farmers, especially in the spring of the year, driving trucks and trailers, and you'll see stacks and pallets of seeds out there on the back of their trucks. Part of what you do is determine the purity of that seed, is that correct?
That's correct.
Okay. What happens, and maybe Doug, this is a question for you because that's your angle there. What happens if you open up a bag of seed and it doesn't perform as it's written on the tag of the seed?
Well, basically that's when we talk about truth in labeling and how the Illinois Department of Agriculture would then have jurisdiction over that. Basically, there's truth in labeling laws that when the inspectors from the Illinois Department of Ag come out to seed companies, they'll sample and do check tests and things like that to see if the label actually meets specifications to within a certain tolerance.
Does that same type of testing go on not only for farmers, but as we see in the spring of the year at all of our home improvement stores and garden stores, we see packets and packets of all types of seed, vegetables, and that type of thing. Does that take place also?
Yes, and when you think of a seed company and the large bags of seed corn and soybeans, typically we're talking about probing the bag, where we have a mechanical device that we stick into the bag to obtain a little bit of seed. With the vegetable seeds, they'll probably take entire packets as a sample rather than breaking things open and getting a few seeds out and resealing it. They'll take just examples from different lot numbers and things like that.
Okay, so the consumer these days is pretty much assured that not only the integrity of the company is going to have a good seed in that packet, but also the work that you folks do keeps an eye on that. Well, we're going to move on to slide number 9 here in just a second, and Gary, I'm going to ask you, seed is, and we talked about it, it's the living part of the seed plus its lunch. So if we go to slide number 9, we're going to take a look at a couple of different seeds there. I believe one of them is a grain of wheat, and another one is a grain of corn. Identify for us those different parts of that seed and why they're important.
Okay, we start at the bottom on the wheat seed, and the radicle is actually what develops the seminal root or the root of the plant. The cotyledon area is actually the earliest food reserve. In monocots such as wheat and corn, there's actually a endosperm area. That's where the starch is at. And actually the brush on the end is, that doesn't have to be there, so that's thing. But what they call the shell in the picture is actually a fruit coat, or a seed coat, if you, in generic terms. Actually, the seed coat's inside the fruit coat. And
then we got corn on the right. The corn seed is on the right. Is that different than the wheat? I see it looks like it's got a few more parts, or they just better identified.
It's very similar to the wheat. It's actually probably a little bit more, you can tell a little bit more because of the size of the seed. Actually, a corn seed, when you bisect it like that, you can actually see almost all of the parts of the mature plant inside the embryo.
We talked a little bit ago about hybrid seed. We see a corn plant growing out there in the field, and you plant one kernel of corn, and up comes the plant, and it grows and it puts on a stalk, and then the ear, one, possibly two. How many seeds does that one corn seed that was planted produce? Is it several hundred?
Several hundred.
Several hundred. Now, is the one that is produced out there on the ear of corn, is it an exact duplicate, or are there changes there?
There can be changes because corn is a cross-pollinated crop, so it could be pollinated by other pollen from another plant, another field. So it would the kernel produced from that plant is not going to be the same. They would call it an F2 thing, so it's not the hybrid that was planted.
Okay. What does hybrid mean when talking about a hybrid seed corn? When a farmer buys a bag of corn, it's hybrid seed corn. What does that mean?
Basically, what they're doing is they're creating inbred lines, which is basically the inbreeding a plant into itself for several generations till they get that to where it's very uniform. And then they cross two of those, or at least two of those, to produce the hybrid seed. So they end up with what they call hybrid vigor, which basically gives a lot more grain yield, a lot more vigor in cutting out of the soil and also producing in the plant itself.
Is it only for the amount of crop, the yield, let's say, of the fruit, or are there other reasons you would breed for a hybrid?
Well, basically, there's a lot of other vigor factors that go into it, but the main thing is the yield from the seed. The farmer always wants to get or the homeowner if they're growing hybrid vegetables in their garden.
Doug, as you go out and look at different seeds, are all seeds hybrid now? Are there other, and what's if it's not a hybrid, what's it called?
Well, basically it's a self-pollinated crop if it's not a hybrid. Soybeans, wheat, oats, those are all self-pollinated crops, and basically you'll get the same variety that you planted because 99% of the seeds are pollinated by itself. You know, the plant provides its own pollen source, and it's not something that outcrosses, so to speak, or has two different parents. So just like children, you know, in hybrid crops, you've got two parents, and then the resulting offspring could be very different from the parents themselves. But with self-pollinated crops, it's very much like the same parent in propagating. And then, of course, there's crops that don't propagate by seeds at all, potatoes, things like that we do cuttings and other propagation means that don't involve seeds.
Well, that's an interesting point. If a potato, there's no such thing as a potato seed, right? Is that what you're saying?
Well, in commercial production of potatoes, they take the cuttings from the actual seed potatoes and plant those into the ground.
Are there other crops that likewise do not come from seeds on a normal basis?
Oh, I'd have to ask Gary on that one.
Gary, what do you think?
Well, there are some that the main way of reproducing the plant is from cuttings or from root stalks, such as horseradish. The horseradish is usually from cuttings from the roots, so that's the type of thing. Although they do produce seed in rare occasions or in the hybridization process, but it's not the main way it's done.
The main problem with those crops is that with a seed potato or something, if you do let it go to seed, those are the unruly children because they've gotten genetics from parents and unknown, and you get a wide variety of off types, or not off types, but offspring. So you know how your children can be very different. You know, that's what they want to avoid. So that's why they go with different propagation methods other than seed.
Is it mainly vegetable or plants that we grow in the garden? Is the open, not the open pollination, but the non-seed varieties, whereas the farmers almost always grow a hybrid type seed? Is that what you see?
Well, they don't always grow a hybrid type seed, but they typically use a true seed to propagate and grow their crops.
Okay. Well, let's talk about maybe hybrids in the garden. You know, some people really are into gardening. I don't know. Do you do much of that, Gary?
I do some.
Okay. So now, are the seeds that you plant in the garden for the watermelon and for whatever crops you're growing, are they hybrid seeds?
Most of the ones I use are hybrid seeds, although they're the lettuce and that type of thing that are basically pollinated type varieties or varieties that are used. But most of the like sweet corn and that type of thing are hybrids. Although some gardeners shy away from hybrid seeds and go with standard varieties.
Mm-hmm. Well, you know, the standard for most people is to go down to the store and buy the little packet of seed and go out there and make your furrow and make that happen. Is there such thing as growing your own seed for your own garden? Is that a possibility?
You can save seed from some varieties, but you want to start with a variety that's not a hybrid to do that, because you're going to end up with a lot of outcrosses if you do. So, but you can save your own seed.
Doug, what about on the farm? Do farmers save their own seed and grow that over and over again for all crops, or none at all? What's your experience there?
They can. Typically, wheat and soybeans would be the primary ones I would think of for on farms. saved seed. If you do save corn, obviously, again, you're going to get all the different genetic possibilities out of that hybrid again. So you've got that set of unruly children again, and you may have shorts and talls, and matures now, matures later, puts a small ear on, puts a big ear on. So if you think back to before we had hybrid corn and some of the open pollinated varieties of corn, that's what they're trying to get away from, is that variability with some of the hybrid crops. The legalities of saving your own seed can be interesting for the farmer. Many of the new biotech varieties are patented and may have a utility patent, so you're infringing on someone's intellectual property rights if you do save some of those seeds. Now, many of the public varieties do have an exemption that you can save enough seed to replant your own ground, but obviously if you go into the business of selling that, you should be entered under contracts or using public varieties as they should be through the certification system.
Okay. We're going to go to slide 11 here in just a second. And Gary, I'm going to ask you the process that's going to happen. We've kind of seen the original seeds. We start out with soybean seeds. We've seen the seedlings, and we've seen the farmer out in the field. Now, take a look at this slide here, and I believe this is also of a bean. Is that correct? What happens? What makes that seed come alive and become a plant?
Well, basically, when you have the conditions that are favorable for germination, you need a proper amount of moisture and enough heat units, that type of thing. They will go ahead and start to imbibe the water. They start to swell. Well, yeah, they go ahead and swell, and there's hormones and that type in the seed that go ahead and kick on the radicle to start growing, the apical or the shoot part of the plant to start growing from the seed, and it'll emerge from the. Basically, a dicot does a kind of a strange thing when it grows. It actually, the root starts to grow down, and then it'll pull up the cotyledons out of the soil, and then the upper part of the plant will grow from that.
So a seed actually is never dead. A seed is always alive, just waiting. It's in hibernation. What would you call that state when it's dry and just sitting in your hand before you plant it?
In some cases, that would be considered dormant, or the thing that it's just basically waiting for the right conditions. Mm-hmm. In some cases, some of the wilder seeds, or even the hard seededness in the field, they'll last till the next year in the field before they grow. Or in some cases, weed seeds, they might last 20 years till the conditions are right.
I've got to tell you the story of the neighbor that was digging out the foundation and put the dirt out in the parking lot where he was digging, and it was a part of the building that had not been touched for 25 years. It rained that night, and 2 days later, biggest crop of weeds came up there that you could ever believe. So seeds hang around for a long time.
Right.
Well, gentlemen, seeds are a wonderful thing. I'm glad we've had a chance to talk about those today. It's a wonder of nature, isn't it?
That's exactly right.
And I can imagine your jobs are very interesting, and I appreciate you spending the time with us today. And that's also why we appreciate folks tuning in and talking with us today. Just like seeds, just like all of agriculture, it's a dynamic business, always one that we're learning each day, and that's why we're glad that you tuned in and found out more about agriculture, seeds today. We'll hope you tune in again next time when we talk more about Champaign County Agriculture Today. I'm your host, Dennis Riggs. Thanks for listening.
Champaign County Agriculture Today is brought to you by Champaign County Farm Bureau.